Welcome to Electrical Machine 1 lecture. In previous lecture, auto transformer, single phase auto transformer, its construction, then comparison with voltage divider circuit, some introduction has been covered. Now we will start the kVA rating of auto transformer. Then comparison of auto transformer with two winding transformer, that is our regular transformer. And the application of kVA, application of auto transformer. So first is the kVA rating. Rating of auto transformer. For example, it is a step down transformer, step down auto transformer. This is voltage V1, applied voltage V1. Number of turns is N1. This terminal is A. This terminal is B, and this terminal is C. And this is for the load. Definitely, this is the voltage V2. Okay, and the current in this one is I1, and current in the secondary or load is I2, whereas the current in the common winding, it is I2 minus I1, because secondary voltage or voltage across load is smaller. So definitely the current will very high as compared to the current in the HV winding. So I2 minus I1. Whereas here the voltage is number of turns is N2 here. Number of turns is N2. Here the number of turn is N2. Number of turns is N2. So here the number of turns is N2 minus N1. Sorry, it is N1 minus N2. Whereas the voltage is V1 minus V2. This is the circuit descriptions. Okay. Now, say let SIN is the kVA or kVA input to auto transformer. So SIN is equal to input to the transformer. It is VAC multiplied by current IAC. Okay, we'll write the current. It is current is here. It is IAC. Okay, so it is equal to VAC, since it is in the same direction. Therefore, it is VAC is equal to VAB plus VBC multiplied by IAC. Okay, which is equal to VAB multiplied by IAC. Sorry, it is IAC, it is not IAB, it is IAB. This is IAB. This is also IAB, and this is IAB. So current IAB plus VBC into IAB. So if you just look at this is one winding, Okay, and this is the secondary winding. Okay, so if suppose it is a transformer, it is like that, two winding transformer. Suppose it is a two winding transformer. This is one winding. This is second winding, where the terminal is A. This terminal is B. Now B terminal is common, so it is B, and this is C. So current and voltage. This is current. Okay, so it is equal to VAB multiplied by IAB is the kVA rating or the complex power as trans. It is due to the transformation action, whereas VAB, it is not a VAB, it is a VBC. Okay, this part is VBC. VBC. This is VAB multiplied by IAB, VAB multiplied by IAB, VBC multiplied by IAB plus VBC. VBC into IAB is the total input kVA to the auto transformer. So this IS power, this one, this is S trans. We can say that it is the power transfer due to transformer action. Okay, transformer action, whereas VBC into IAB is the power transfer due to conduction. So transformer input SIN is equal to S trans plus S conduct. Okay, so the kVA rating of the transformer is comprises of transformation due to power transformation due to the transformation action and power transfer due to the conduction action. So what is power transfer due to transformation action? So T trans is equal to VAB into I1, okay, plus VBC, it is VAB. VBC is nothing but V2 into I1. Okay, this is the by which we can say that it is the transformation. So the kVA rating of auto transformer is greater than the kVA rating of two winding transformer. If suppose same capacity of a transformer is taken as a two winding transformer, then the power transfer by the auto transformer is greater than the two winding transformer. So it means that if two winding transformer is connected to auto transformer connection, then auto transformer kVA rating is more. Okay, so kVA rating, suppose 5 kVA two winding transformer, it is connected in the auto transformer configuration, the kVA rating will be the more than the 5 kVA, isn't it? How much it is? See, we will see one by one. Now we will consider that the by different meaning, different way to understand the kVA rating of auto transformer and kVA rating of two winding transformer. Okay. Say here it is V1 minus V2. Okay. Now let we consider that transformed kVA, transform VA or kVA. Suppose it is a kVA. So because we are more familiar with word kVA, so we will consider this a kVA. Hello. We will consider only the kVA for our simplicity. Because auto transformer has two type of kVA rating. One is the transformation action kVA rating, and second due to the conduction. So the power which transforms with the voltage multiplied by the current I1 is nothing but the conduction kVA rating. Okay, divided by input kVA. Input kVA, or simply it is a VA. Don't be confused. VA rating. Okay, it is equal to transformed VA. It is V1 minus V2 into I2. See here, VAB. This is VAB. What is VAB? With A to B multiplied by IAB. We have written as a transformer kVA, which is transformed by transformer action. And VBC, this is B to C multiplied by IAB, same current, is the conduction current. So what is the input? Input is V1 into I1, whereas kVA transformed by transformer action is A to B multiplied by current. So it is equal to V1 minus V2 into I1. See, this part is N1 minus N2, A to B. VAB is equal to V1 minus V2 into I1 divided by input. It is V1 I1. So which is equal to V1 I1 minus V2 I1 divided by V1 I1. It may be written as 1 minus V2 upon V1. Okay, this is the ratio, or we can write as 1 minus 1 upon V1 upon V2. Okay, V1 upon V2, which is equal to 1 minus A, where A is equal to V1 upon V2. That is the transformation rate. So it is equal to transform kVA is equal to 1 minus divided by input kVA or VA or VA, isn't it? So it means that the transformed VA is smaller than 1 minus A. Let A is equal to, means voltage is 200 and secondary voltage is 50. So it is 2. A is 2. Sorry, it is 1 by A. So it is 1 by 2, means 0.5 and 0.5. It means that transformation is done only 50%, and rest of 50% is the conduction. Okay, we can write as, or conduct V. Second ratio, first ratio, second ratio is conduct VA or VA divided by one input VA is equal to conduct VA VBC. This is V2. into current I1 divided by V1 I1. So it is simply V2 upon V1, and V2 upon V1 is V2 upon V1 is nothing but simply it is A. Okay. So here it is, just a minute. This is as it is. This is 1 minus A. Okay. This is 1 minus A as it is. Okay. It means that the transformation VA is smaller than input VA. Okay. This is the meaning, and therefore the part of that input is going to appear because of the conduction effect. Okay. So this is the this is our what we can say that it is the ratio of input transformation kVA divided by input kVA. Now we will consider as a very important. This is somewhat is very useful for as a auto transformer. Okay. So we will consider here again, say step down transformer. We will redraw this figure for better understanding. So this voltage is V1. Number of turns, total number of turns from A to B, A to C is N1. It is terminal B. Number of turn is N1 minus N2. This is the voltage V2. Number of turns is N2 here. Current is I2 minus I1. And here it is V1 minus V2. The current is secondary terminal is I2, and primary terminal is I1. Okay. Now, say first we will take as a step a down transformer, a step down transformer, auto transformer. Okay. In step down auto transformer, kVA rating of auto transformer divided by kVA rating of two winding transformer, because here this is one winding, this is second winding. It will make a total primary winding, and secondary winding is taken from the second winding. That is it will make as a means simply a two winding transformer is converted into the auto transformer, which is equal to what is the kVA rating of auto transformer is here. This is the voltage and this is the current V1 into I1 simply. Whereas as a two winding transformer, we will take this winding, one winding. So in case of two winding transformer, the kVA rating of both winding is same. Either we will take from primary side or secondary side. Say it is equal to VAB into IAB, which is equal to V1 I1 divided by what is voltage between A to B. It is V1 minus V2 into current IAB I2B is again I1, it is I1, which is equal to V1 I1 divided by V1 I1 minus V2 I1. Okay, it is V2 I1. So it is, if suppose divided by V1 I1, so in numerator 1, in denominator, this become 1 minus, it is V2 I1, V2 I1 divided by V1 I1, it is equal to 1 upon 1 minus I1 get cancelled, say it is A, where A is where A is equal to V2 upon V1. It means that kVA rating of auto transformer is equal to 1 upon 1 minus A kVA rating of two winding transformer. No doubt the two winding transformer rating and which we are considering is on the same kVA ratings. Okay, means suppose we have considered 2 kVA two winding transformer, it is get converted into the auto transformer. What would be the kVA rating? Now let here suppose kVA rating, let V2 upon V1 is equal to 2, means V1 upon V2 is equal to, say, instead of this one, say we can consider as V2 upon V1 is equal to 0.5 because it is a step down transformer. It is a step 0.5. 0.5 means suppose the voltage is 100 here, the voltage will be 200. So it is a step down transformer. Under such condition, it is a 0.5, 1 minus 0.5 is a 0.5. So it is kVA, under that one, kVA auto transformer is equal to 2 multiplied by kVA of two winding transformer. So, two winding. So it is quite clear that the kVA rating of auto transformer become double if it is if the two winding transformer is connected into the auto transformer, the kVA rating will be double. And why it is double? Because part of the kVA rating is due to the transformation action, and voltage V2 multiplied by the current I1 is the conduction kVA rating, isn't it? Let it is a 0.5, then again it will be higher. Okay. Now second point, we will consider that it is a step up transformer. What would be the change in kVA rating for the step up transformer? Okay, so we will consider as a step up transformer. Be careful in doing this calculation. So the secondary voltage is greater. Here voltage is say V2. Number of turns is N2. Here the number of turns is say N1. Current is I1. Voltage is V1. Terminal A, B, C. Okay. Now here the secondary current I2 is greater. This is I1 and this is I2 is smaller because of the high voltage winding. So it is I1 minus I2. Okay, this is I1 minus I2, whereas this term is V2 minus V2. Okay, because V2 is greater. So V2 minus V1, and at the same time N2 minus N1. This is the number of turns divided in the total winding is there. Okay. Now, so second part is step down. step up transformer. No doubt it is an auto transformer. So again, we'll consider the kVA rating. kVA rating of auto transformer divided by kVA rating of two winding transformer. Okay, so it is a sorry, auto transformer. What is the kVA rating of this one? We will consider that the secondary. Either we can consider the kVA rating in the primary winding, kVA rating in the secondary winding, in the our simply two winding transformer. So it is quite same for the auto transformer V2 I2. Okay, divided by kVA rating of two winding transformer, which is equal to this is V2 minus V1 into V2 minus V1 into V2 I2, sorry, this current I2. This is the term. So it is equal to V2 I2 divided by V2 I2 minus V1 I2. It is equal to, if it is divided, so it is 1 in numerator, in denominator is 1 minus V1 upon V2. I2 get cancelled, V1 upon V2. Okay. Now in the previous section, see here, we have written A is equal to V2 upon V1. Let here we write as a K is equal to V1 upon V2. So therefore, the kVA rating of auto transformer means the auto transformer, two winding auto transformer is connected, two winding transformer is connected into the auto transformer is equal to 1 upon 1 minus K into kVA rating of two winding transformer. Okay, let K is equal to 0.5. What is K is equal to 0.5? It means that it is equal to K is V1 upon V2. When it will be 0.5? When, say, for example, the primary voltage is 100 volt, as we have considered, and the secondary voltage is 200 volt. So it is a step-up transformer. So it is 100 divided by 200. So it is a 0.5. The ratio which we have taken earlier is 1:2 ratio, 2:1 ratio. In the previous case, see here. In the previous case, it is 200 by 100. So the ratio is 2:1. The ratio is taken same ratio has been taken here. Only as a step up transformer, it is 1:2 ratio. Means if the same transformation ratio we have taken for the auto transformer, then kVA is equal, K is equal to 0.5. It is 1 upon 1 minus 0.5 is equal to, this is term is equal to again 2 multiplied by kVA rating of two winding transformer. It means that a two winding transformer is converted into the auto transformer. The kVA rating is more than the two winding transformer, isn't it? And the how much percentage? It is same for the step up transformer and step down transformer. It is common for the step up and step down. So this is a very important conclusions up to this one, because when we are going to compare the two winding transformer and single winding auto transformer, So first point is that number one, it is kVA rating, of auto transformer is equal to kVA transform because of the transformer action plus kVA conduct. So there are two type of kVA rating. One is the transform kVA, and second is the conduct kVA. Second, the second point is kVA rating of auto transformer is greater than two winding transformer. Okay, simply if two winding transformer is converted into the auto transformer, either it is a step up transformer or step down transformer, the kVA rating is always higher. Okay, this is the meaning. Now, the third important point is the volume of copper required for auto transformer is smaller than two winding transformer. It is quite simple by this observation, because only this is one winding, and part of this winding, suppose it is a step up or a step down transformer, like it is a step down transformer. Suppose we are taking a step down transformer. Just a minute. Okay. So this is the step down transformer is there. This is V2, and this current is I1, and the current in the common winding is I2 minus I1. Okay. So it means that the current I1 is, and current I2 minus I1, again it is very small. So the number of turns which is common in the primary and secondary winding, we may kept is a small thickness or smaller thickness conductor. So there is a saving of copper. But how much is saving of copper? Therefore, it has to be examined with the help of some example. So we take volume of copper. Say step down transformer, step down auto transformer, V1, number of turns is N1, voltage is V2, number of turns is N2, A, B, C, current I1, current I2, common winding, the current is I2 minus I1, because the secondary voltage is smaller, so current is higher one. Number of turns N1 minus N2. Similarly, the voltage will be V1 minus V2. This is the step down transformer. Now, here the number of turns, or we can say that NAB and A to B is equal to N1 minus N2, whereas NAC A to C is equal to N1 and B to C is equal to N. Okay, this is the things. Now, volume of copper is directly proportional to length of the conductor, isn't it? Length of wire or winding multiplied by cross-sectional area, isn't it? Cross-sectional area of the conductor. Now, length of wire is directly proportional to number of turns. More the number of turns, more will the length of wire. Number of turns n. Okay. Similarly, cross-sectional area of conductor is directly proportional to current flowing in the conductor. So it is a current, isn't it? So we can write as volume of copper for auto transformer divided by volume of copper for two winding transformer, the ratios. So volume of copper in auto transformer will be equal to number of turns N2 and current flowing in the this one. Okay, say number of turns is N2 multiplied by the current. It is the volume of copper is length multiplied by cross-sectional area. Length is directly proportional to number of turns and cross-sectional area is depend upon the current. So N2 multiplied by I2 minus I1. Okay. Plus second one, it is N1 minus N2 into current I1 divided by if it is a two winding transformer, N1 I1 plus N2 I2. So if you just open this bracket, it is say N2 I2 minus N2 I1 plus N1 I1 minus N1 N2 I1 divided by N1 I1 plus N2 I2. As we know N1 I1 is equal to N2 I2 as a balance MMF. This is the MMF simply. So here the total value is become, if put the value of N1 I1 in term of N2 I2, so it is equal to twice N1 I1 minus 2 into N2 I1 divided by twice N1 I1 which is equal to say which is equal to, if you take the common value over here, so it is twice I1 into bracket N1 minus N2 divided by twice N1 into I1. So this one, this get cancelled, and it is N1 minus N2 divided by N1. So it is equal to 1 minus 1 N2 upon N1. And as the transformation ratio, N1 upon N2 is equal to A. So it can be written as 1 minus 1 upon A is the volume of copper required, isn't it? So it means that volume of copper, volume of Cu for auto transformer is equal to 1 minus 1 upon A into volume of Cu for two winding transformer, isn't it? Let N1 upon N2 for this above circuit, or this one means this one. What is A? A is equal to N1 upon N2. So number of turns N1 is greater and N2 is smaller, isn't it? N1 is greater and N2 is smaller. So it means that let N1 is greater, and again it will take the ratio is equal to 200 voltage by 100 volt. So it is 200. So it is a 200 turns divided by number of turns is 100. Is 100 turns and ratio is 2. So under such condition, 1 upon 2 is 0.5. So it is a only 50% 50% copper required, 50% copper required as compared to the two winding transformer. So therefore, saving of copper is 50%. Okay, saving of copper is 50%. If A is equal to 4, or A is equal to say 4, then saving will be point. Say A is equal to 4, means the ratio is different. So under such condition, 1 upon 4 is equal to 0.25, and hence we can calculate the saving. So in short, the kVA rate auto transformer save the copper in case of two winding as compared to the two winding transformer.